Hello team, this is Francisco Vargas from the Cisco Tag Switching team. Today, I will show you how to troubleshoot spanning tree issues and validate the correct features for this protocol. These procedures are the same for all Catalyst 9K switches. I want to explain quickly the BPDU Guard, Root Guard, Loop Guard, and PortFast features for this protocol. Spanning tree help us to avoid layer 2 loops and broadcast storms in our network environment, and we can add additional features to enhance traffic flow and converge, such as BPDU Guard, which help us to protect our network from other external switches. When a BPDU from another switch is received on our designated interface, the feature immediately places this interface in the error disabled state to avoid STP inconsistency. Root Guard. This feature is necessary to protect our root bridge. When you enable this feature, even if a superior BPDU is received on the interface, the switch does not accept the new switch as the root bridge, and the interface is disabled. Loop Guard protects our non-designated ports using additional checks. When an interface does not receive BPDUs after 20 seconds, STP assumes that the interface can proceed to the forwarding state. So this feature prevents that transition and sets the interface in the blocking state during converge. PortFast. This feature helps us avoid transitional states in STP. When an interface comes up, it transitions directly to the forwarding state. It is recommended to configure this feature on access ports, as it prevents the interface from participation in STP and avoids the transmission of topology changes notification. On your switch CLI, you can check this to start spanning tree troubleshooting. You can start by displaying the show spanning tree command to validate the STP roles and states for the VLAN and interfaces. It is necessary to validate which switch acts as the root bridge, since this is the only switch that generates BPDUs. STP uses a type of control plane packet for communication called a bridge protocol data unit. Additionally, you need to be aware that after switches compare the lower MAC addresses, the other tiebreaker is the priority number. But the system always defines the port priority as the value 128 plus the interface ID number, which means that Gigabit Ethernet 1/0/13 is lower than Gigabit Ethernet 1/0/14. Another useful command is show spanning tree summary. Here, you can check the list of each VLAN and see how many interfaces are in each STP state using the STP active column as a reference. Additionally, you can check if you have enabled additional STP features and the path cost method used in spanning tree. It is suggested to align the long path cost across your network to avoid unexpected converge during an STP transition. Despite having our STP protocol enabled on our switches, you can encounter some unexpected scenarios such as spanning tree loop guard block and spanning tree root guard block, and we can perform this troubleshooting. In this scenario, we found this unexpected state, which is broken state on STP, and loop in log, which means loop inconsistency. If we get more details in our logging buffer by applying a specific filter for spanning tree, we can observe that loop guard blocked our interface in STP. But please note that the interface remains up. Checking additional details such as BPDU counters in show spanning tree interface G1/0/10 detail, we observe that BPDU counters do not increment every 2 seconds, and the status is still broken with loop inconsistency. Finally, if we check the link on the other side of the connection, the BPDU filter feature was set, which prevents this port from the transmission and reception of BPDUs. Normally, loop guard acts during a non-directional link failure for Ethernet networks or in a loop scenarios to protect your network and avoid unexpected behavior in your traffic flow. In our network, we have defined our root bridge switch, but in this scenario, I found that my uplink interfaces came down after the installation of a new switch in my network. Checking the login buffer, I can notice some logs related to root guard enable, disable, and blocked interfaces. If I apply the show spanning tree inconsistent ports command, I get the main reason for the issue, which is a root inconsistent problem in my VLANs. Also, we can observe the same status and broken state in the show spanning tree command. Then, by check my new switch added, I observe that my priority on my VLANs was set to 0, which can be a problem since this new switch sends superior BPDUs to my root bridge. After this validation, I proceed to change the priority of my VLANs in this new switch and set a higher priority to mitigate the superior BPDUs to my root bridge. Finally, in my root bridge, I observe that root guard unblocks the affected interfaces and I do not have any issues in my STP environment. You can also use the debug tool on your switch to get more details about the STP process and transitions, such as topology changes, superior BPDUs received, and the transmission of proposals for the STP status. You can set debug spanning tree events command. Then, in the login buffer, you can find the debug details in your STP topology. At this point, you have the procedures to troubleshoot spanning tree in different scenarios. Do not hesitate to contact tag support if you have any other doubt, and check the tag video portal for more.